Hey, welcome back, students. In this video lesson, I want to go ahead and talk to you a little bit about the atomic composition of matter. Okay, so let's talk about the composition of matter. Now, we learned in a previous video that matter had to be, or that had to meet two conditions. One, the first condition was that it had to have mass, okay? And then the second condition was that it had to actually occupy a certain amount of volume, okay, or occupy a certain amount of space. These are two conditions that matter does have to meet. However, let's look a little bit about the types of matter or the phases of matter. There's three of them in particular that we're going to be looking at in this particular section, and that is going to be the solid, the liquid, and the gas. Okay. Now keep in mind, whenever you're seeing a formula of some sort associated with a compound or a substance, we've got to make sure that we also notice that the little s in parentheses, the little l in parentheses, and the little g in parentheses, each of these refer to solid, liquid, and gas respectively. Now that we know that, the other item that we need to kind of look at here is what happens when we compare these three phases with respect to the atomic composition. Let's go ahead and take the solid first. Okay? So whenever we're talking about the solid is going to be one of those things where you're going to be looking at the atoms in a very specific way. So the arrangement of a solid are going to be kind of like this. Notice the atoms are really close to one another. And if I were to put them all together, let me just get a whole bunch of them here. You're going to see that the atoms here of this particular arrangement are going to be extremely compact. Okay? So the atoms here are going to be compact. And so it's going to put this here. They're going to be compact. In other words, there is little space between the atoms. Okay? And so the atoms are not able to move very much. And since there's very little space, one of the items here is that if I were to put this into a container and try to compress it, there's going to be very little to no compression. So we'll just say no compression. Okay? This is for the solid. Now let's go ahead and explore the liquid. Now the liquid's going to be slightly different, although not too different, but the solid here is going to be the following. The liquid is going to be very similar to the solid, but what we'll see here is going to be a little bit more spacing in between the atoms, not too much, but just a little bit more. And the reason that we see this is because the atoms here for a liquid, the atoms are going to be able to move past one another with a little bit greater ease. So here the atoms, they're going to be close to one another. Let me just rewrite that a little bit. There is still going to be very little space. Okay? But here when we say that the atoms are close, they can move a little bit. And that's what allows a liquid then to be able to move in a container when you put it into another container. Like the solid, the liquids are not compressible, so there is no compression associated with the liquid. And now that brings us to the gas. Now the gas is slightly different in the sense that here, when we actually draw the atoms, and let me see if I can draw the atoms in a pretty bright color. Let me use like a bright yellowish color here for the gas atoms. So the atoms here would be kind of something like this, and although these are not going to be drawn to scale, you're going to have atoms figuratively kind of like this. And I know I'm not drawing it very big, but let me just highlight them to see where they're at. See, there's a dot right here, there's a dot right there, a dot right there, and a dot right here. Now the thing to note here is the tremendous amount of space in between the atoms. So there's going to be a lot of space here, okay? So the atoms here for a gas are going to be very spread apart. In other words, there is lots of space involved here, or that you observe in a gas. Because there is a lot of space, it follows that compression is possible for the gas. And this is going to be different from the solid and the liquid, in which there was no compression. Okay? One other item that we do need to take into account here is going to be the rigidity or not rigidity or fluidity of a substance. Whenever we look at solids, solids are pretty rigid. And we know that already because the atoms are already compact. Okay? So they're not going to take the shape of any container if you put that into a container. The liquid, however, We say that liquids are fluid. No pun intended there, but essentially what this means is if I were to take a liquid, put it into a container, it would take the shape of the container that you put it into. And that is going to be the same for the gas. It also assumes a fluid type appearance or structure, so that if you do put it into a container, though you might not be able to see it, it will take the shape of that particular container. So from an atomic perspective, this is kind of the way you want to determine or distinguish between a solid, a liquid, and a gas. So hopefully that's helpful for you. Go ahead and subscribe. Keep watching, keep learning, and we'll see you in the next video.